when finding the derivative of a function from consideration of the limiting value it is called differentiation from first principle. Now let's see how we can differentiate from first principle the derivation of the function f of x equals to x squared. F of x equals to x squared. You know that from the function if you're asked to differentiate from first principle, and you're asked differentiate from first principle y equals to 2x plus 4. You have to differentiate that. Now, there's what we call a smaller increment in y. If you plot the graph of y and x-axis, the slope of the graph is a continuous process starting from point 0. As it increases to x, it also increases to y. So if y is increasing with a smaller increment, and if x is increasing, it's also increasing with a smaller increment. So if we want the differential of first principle, we introduce the smaller increment in y wherever we see y, and introduce a smaller increment in x wherever we see x. So from that we now say you can put a smaller increment like this for the x, any of this function here. So if you put a smaller increment, say y plus change in y equals to 2x plus change in x plus 4. You see that from there, my y plus my change in y equals to, open this bracket, 30. What's the problem? What is it? It has to be a yet. So, yes, open this by what do you have? 2x plus 2 change in x, right? Plus 4 minus y. This y causing me by the quality side. So that my change in y will now be equals to what? 2x plus 2 change in x plus 4 minus, replace y, 2x plus 4. So my change in y will now be what? 2x plus 2 change in x plus 4 minus 2x minus 4. Okay? So this and this is gone, right? Is that true? This and this is gone. What do you have? Change in y equals to 2 change in x. So dividing both sides by changing it, what do we have? Change in y over what? Change in x equals to 2 change in x over. So what do you see now? My change in y over change in x will now be equals to 2. All right. Are you consoling him on the mat or we don't? I said I'm here. Okay, you are consoling him that you are enter calculus. He has a heartbreak. Robert, did you take that drugs? I've taken the drugs. Sorry. Let's just be on our feet. Just be on our feet. Let's be on our feet. And just stretch your body like this. Just stretch your body like this. Just do like that. It's good. It's good for you. Professor, you don't understand English. Stand up. Oh, yeah. Okay. All right. All right, sit down. Let's proceed. All right. Now this is what is happening. Name as change in x tends to 0, f of x plus change in x minus f of x divided by change in x. There's the formula to derive. I am going to use this one also to show you. Sometimes you can see some textbook and write like this. It's a name as h or any alphabet change to 0, f of x plus h minus f of x all over h. You are seeing the same stuff. Get such expression. That is the differentiation from first principle. Should I off this fan for you? You enjoy the fan? My very serious students. How are you? Did that woman open your book? And you have incomplete mirror. You have complete mirror. See complete mirror this man has. There are people that has complete mirror, but they don't open. All right. Now, if you have, I want to explain this again for you. In differentiation from first principle, is that I use this formula. It's the same thing here, or you just do this. Now, how do we do that? When I give you a question to differentiate, whenever you see x, you put a smaller increment in x. Whenever you see y, smaller increment in y. X, smaller increment in x. So this place down there is y. Look at it, smaller increment in y. X, smaller increment in x. Now y crosses over to the other side of the equation. When it's crossing, and now expand this x, I'm fixing the value of y given. That's why you see that now the minus affects the bracket. So when the minus affect the bracket, you now open that bracket that you see there. When you open the brackets, the minus comes into half, minus 2x minus 4. So 2x minus 4 is gone, 4 minus 4 is gone. You now have this left. So for you to be able to get the y over the x, you have to divide both sides by changing x. You divide both sides by changing x, the answer gives you 2. But if you want to use this method now, what you do there is that, if you want to use this one, you just fix in the value. You fix in the value there. What you do there is that you start by writing that expression. When you write that expression, you say lim, because the limit value as change in x tends to 0, f of x plus change in x minus f of x divided by change in x. So the question I gave to you was differentiates y equals to 2x plus 4. I mean, this y equals to f of x. This is f of x. The equation I gave you is f of x. I mean, so if you have f of x equals to y equals to 2x plus 4. So if I write something like this place is for this, I mean, now if I have f of x plus change in x, it means whenever I see x, I put this. That will be what? 2 into x plus change in x plus 4. I mean, this is just by the way. Give you a clue what we want to do here. So coming to this now, you now say solution, differentiate that solution. I want to differentiate this. What I now do, you now say lim as x tends, change in x tends to 0. This place of f of this now, what was the question? So I now write like this, 2 into what? X plus change in x plus 4. Let me shift so that I have space. I don't want to clean the other one. That is, bring the formula down. Lim as x solution. Lim as change in x tends to 0. F of x plus change in x minus f of x all over what? Change in x. So that will be equals to this. With respect to this question now, I'll put this in that place. Are you following me? Hello? So that place will now be what? 2 into x plus change in x, okay? Plus 4, that is f of that, just like what I've told you here. Are you following me? Yes, sir. Twin, prominent twin, minus f of x given. This is f of x. Y is f of x. Copy and paste. What do you have there? 2x plus 4, but you need to take note of the minus, because the minus will affect the bracket. Divided by what? Change in x. So open this bracket, what do you have? Plus what? Change 2x plus 2, change in x plus 4 minus 2x minus 4 divided by what? So something must kill a man. This and this is gone, okay? What else? So therefore we have what? 2 change in x over this, cancel this, okay? The answer equals to what? 60 get what we had when we were solving it. Which one do you prefer? There are some questions. There are some questions you cannot solve with this one. Are you hearing me? There are some conjugate questions that if you don't use this method, you can't solve. Eh? Thank God you know. So please. Eh? So if they give you a value like y equals to x squared and you're asked to differentiate from first principle, does it differentiates from first principle? What you need to understand, don't differentiate from the general formula when the question was to use first principle. You score 0. So capital 0. So, are you sure with this? Can I clear it off? Eh? You finish the other side. You can try this for me while I'm waiting for people to finish. You have y equals to x 3x minus 4, y equals to x squared plus 2x minus 5. 3 y equals to x cubed 2x cubed plus 4x squared. Number 4 equals the square root of x plus 3. This is what we want to solve from first principle. Eh? I'm not saying, I said that's what we want to solve, but just try that number 1 for us, what you are going to do while we are warming up for the business. You have finished number 1. What do you have? In number 1, number 2 was the answer. Okay, just use general formula. You guys are funny. The video you won't have your hair for what got there. Intimidation is allowed. Intimidation is allowed. If there is any topic that I like teaching most, is this calculus. These ones I don't even need. I'm just carrying books so that make it feel like say I don't follow outline. Say carry book. I don't like carrying books to teach maths. But you need to carry books so that it will be part of your assessment. Most of the things I don't even look book now. I just copy. I don't even remember why I give the books. Logic. But the logic was sweet now. I was flowing. You did not learn something. Benny, are you following? This one you are saying as if you want to take passport. Math-A-Thon, no be some place because they sit down, they blow. Alright, please have you tried something? At least this one we are sitting down, we will not waste time before 19 this evening we finish. Let's try and finish differentiation from first principle today. We are counting down. Very soon, we'll reach half of our target. Yeah? If you divide 150 by 2, what is it? Then 150 divided by 2 is how many? 150 divided by 2 is how many? $650. I want them to go work. Have you finished number 1? I'm not talking about general formula. Can I clean this? I want to clean everything and proceed. Are you true? You are still writing. Get it? I've only anyone will. Whatever in bag of the body. Okay, active. All right. This is the first time in my life I'm teaching. I control myself of comedy. Okay. Now, let's see how we can differentiate y equals to x squared plus 2x minus 5. Says what? Y plus yes. I don't understand what you're saying. Okay, it's the answer. What is the answer? Wait, telling me the answer. From first principle now, that's what I mean now. All right, can I proceed? Last born. How are you? All right, now y plus change in y equals to x plus change in x all squared plus 2 into what? X plus change in x minus 5. Have you seen what I'm doing there? So from that level, my change in y will now be, I expand this to, have you? The expand is what do you have? X plus change in x, eh? X plus change in x. Have you seen that? X plus change in x. Now, you expand this plus 2x plus 2 change in x. Then you now have this x plus change in x. Now this is 2 of this. Minus 5. Then minus y. That's how y crosses. Abi? So now from there, you now have my change in y to equals to expand this. X x squared plus what? X changing x. Have you seen what I'm doing? Plus x changing x plus changing x all squared plus 2x plus 2 changing x minus 5 minus, open the bracket, open y, x squared so therefore this will now be x squared plus x changing x plus, this is 2 of that, have you? 2x changing x plus changing x all squared plus 2x plus what? 2 changing x minus 5 minus, open the bracket, right? So x squared minus x squared is gone, plus 2 minus 2 is gone, minus 5 plus 5 is gone. Is that right? So this will now be equal to 2x changing x plus 2 changing x now dividing through by that. Now dividing through by changing x, it will now be 2 changing x all over changing x, have you? Plus what? Changing x square over what? Changing x plus 2 changing x over what? So this cancel out this, that will be what? 2x plus what? Changing x plus 2. You reach the left as changing. Alright. So you see, to eat that. So that value if you expand that point, so x plus change in x x plus change in x. So you have to expand it. Now, just like I said earlier on, that y plus change in y, half an hour. Okay. I mean what? So when you expand this, you have this. But it good job. You think they have. All right. Now you see, when you have y equals to x squared, what's the value to write? Are you guys finished? All right, let's solve other examples. All right, this is time for question session. This is time for question session. No, please call me out. I'm sleeping. All right, this is time for question. All right, please, what's the question?
How did the y appear? That change of y appear? That's y. Then the expansion like this, expansion principle.
What is one differentiation from first principle? Just follow the example, just follow the word on the last much more you understand. That's the same principle. You think it's just expansion. Forget about that mode. Say mathematics now. I still asking just on the math. All right. All right. So question time is over. All right, now let's try to solve. I want you guys to try something for me. Use this method and solve this math for me. Let's see how it goes. Y equals to x squared plus 3x. Please solve this for me. Sorry, that's typing error. Just try that one, let's see.
This one.
Sorry, they soon be fine, eh? All right. So just try to see how you can do that expansion using first principle. Differentiating from first principle. Is that the question? Let's just try, let's see how it goes. Don't forget that when they give you any differentiation, you have to apply any of the method to solve it. So just try, let's get the value 2x. Is it from first principle? Which method are you using? Which method? Okay, what do you have? You don't do your own. Near up the tail. So don't forget that if you just put a smaller increment in x, wherever you see x, put a smaller increment in y wherever you see y, the value will come out. I say I'm trying to explain to you how they solve it. But that's trying now. So that it gets, and when you now expand, reaching yeah, do like that now. Have you done it this way? If you have solved it, following the same process. Have you done something?
We are waiting.
I'm not going to drink that. No, I will not drink that chocolate around the walls. Have you gotten? Any person have gotten that answer? What do you have? Eh? I will do it. I will solve it. What? Okay. On a normal, it's a no fun camera. All right, let's go. All right. Let's just we want to see how we can expand let's see how we can. I gave you a second question to do for me, right? Which one were you doing? Which one were you doing? Where was the x squared plus 3x plus 4? That was the assignment I gave to you. Last one. But have I expanded x squared here? I believe you know how to do that one now. Eh? Let's do y equals to x to the power of 3. Let's do this one first. This is y plus changing y. So, changing y will now be what? X plus changing x, x plus changing x, x plus changing. Is that? You can see do it. Minus y. So this will now be changing y equals to 2x changing x plus changing x all squared. That's for the 2. Okay? So from there, this one expand this using x first. This times this is this. This times this. This times this. Okay? Now, this times this. X squared changing x. 2x changing x all squared. That is, this goes for this goes for this goes for this x x squared this with this with the x plus 2x changing x squared by changing x all cubed. Where we are either one more. You want to make one more. So, yeah. Now let's expand that. We expand this. Is that correct? So sorry. Now if you expand that minus y and y was x cubed. All right. Now, this and this is gone. Abi? So, we bring out that value that might change in y equals to this. So, we can divide all through. We can divide all through by changing y. So, that will be changing y by changing y over changing x over changing x plus x changing x squared over changing x plus x squared changing x over changing x plus 2x changing x squared over what? Changing x plus changing x all cubed over changing x. I'm dividing all through by that. So by so doing, this cancel out this. This cancel out this. You have changing x. This cancel out this. This cancel. What do you have here? Changing x. This was what? Changing x squared. So by so doing, you have that this will now be equal to what? 2x squared plus x changing x plus x squared plus x squared plus 2x changing x plus changing x squared. So from there, now say as changing x tends to 0, 2x squared, if you add this, you have 3x squared plus 0 plus 0 plus 0. You don't pass place now, suppose add up. So that is equals to 3x squared. Even though you add or you don't add, you still get the same answer. How come, sir? So, what? You want to go break? Yeah, I don't have any problem. People want to go break. No, me, I don't have any problem. Eh? So let's proceed. Now, I want to go to the next question now. I'm fine. So this is the expansion of x to the power of cube. If you want to apply the other method, you have something bigger than that. So let's see how if you have the next question was, this was question number what? Question 3. Question 3. All right, question number 4. Are you through with this? Are you through? Question 4. Question number 4 says, square root of x plus 3. Y equals to the square root of x plus 3. So, leave as x tends to 0, f of x plus change in x minus what? F of x, right? Huh? Okay? Okay, I see. Divided by change in x, okay? So that plane, my root, this is that. So you have that this is going to be the root of what? The root of x plus change in x plus 3 minus the root of what? X plus 3 divided by change in x. That is what you have there. So from there, you rationalize. Are you? Is that right? So when I rationalize, we have this will now be equals to the root of what? x plus change in x plus 3 minus the root of what? X plus 3 divided by what? Change in x. Multiply by the conjugate. The root of what? X plus change in x plus 3 minus what? Plus the root of x plus 3, have you? Divided by what? Plus. Is that clear? So that will be different of 2 squares, have you? So that will be equal to the root of x squared plus change in x plus 3 all squared minus what? The root of x plus 3 all squared divided by change in x in the what? The root of x plus change in x plus 3 was the root of what? X plus 3. So let's cancel out this, have you?
Yes, sir.
What do you have?
X squared plus change in x plus 3.
Is that?
X squared plus
x squared
change in x plus 3.
plus change in x
Yeah,
minus x minus 3. Minus will affect this too. Divided by what? Change in x into the root of what? X plus change in x plus 3 plus what? The root of x plus 3. Is that true? So from here, don't forget this was this and this is gone. Okay?
yes, sir.
This place was x. You have x here plus 3. This place was x. This was it x squared? In that question, was it x squared? Was x plus 3? Was it squared? Check the question. There's no x here now. There's no x here. So this x, cancel this x, I mean. Don't forget, what happened here was what? There's a change in x down. This one counts itself 1, I mean? Because 1 is remaining here. So that place will now be what? This is 1 over the root of x plus change in x plus 3, have you? Plus the root of x plus 3. Is that right?
Yes, sir.
This one tends to 0. So that will have what? 1 over the root of x plus 3 plus what? X plus 3. That will be 1 over 2. That's the stuff. Doesn't matter. Let's copy that so that we can do some other thing. My speakers. Okay. I'm copy now. I'm going to make out the phone. So let's do the next one. Because we have over 50 questions to solve before 6 o'clock. After first principle, enter the next level. I need to do different varieties of first principle. I want me to do one question and stop. Eh? What do you say? Eh? But when they ask in the exam using first principle, what do you do? Will you run away? We're getting a 5-minute break.
Okay, you know, from the hours and that we the west. I'm out of 340 equal to
I'm going to 340.
I'm out of 340. they are 1 hour for Lambo charge, so we cannot get something.
All right. Have you finished this one? So I should clean this off. Which one? It still work. If you use that one, it still work. What you do is that, is it enough for you to know? Just y plus change it. The root of x plus change in x minus y. You now rationalize. Times this over that. Right, still the same thing. Or should we solve it? If you want to use, no problem. Now I say correct. What do you say? It's still correct. Can I clean this up now? All right, since we'll be able to solve that, let's try to see how we can do a complicated one higher than this before we now go to the next another topic. If they give you a question, say y equals to x to the power of 3, that is 2x cubed plus 2x squared minus 3x plus 4. Now they say differentiate from first principle. That my friend doesn't like first principle. I don't know how she will do. Because these are the questions you likely see. So now solution. This is a question what? I mean, which question number what is this? Number 1. No, I mean from this topic. Number 5. All right, now, what do you know is in a y plus change in y. Are you following me?
Yes, sir.
Please look up. Y plus change in y equals to 2 into x plus change in x to the power of 3. I mean, plus 2 into x plus change in x. Is that right? Squared. Minus 3 into what? X plus change in x. Are you there? Plus what? 4. Is that right? So from there, so therefore my change in y will not be 2 into expanding this will be x plus 2x change in x plus change in x squared. That is for 2. then x plus change in x, then plus 2 into x squared x squared plus 2x change in x plus change in x all squared for this place, okay? Then don't forget there is 2 there. For this, minus 3x minus 3 change in x plus what? 4. Then minus y, that's the value of y in the other side. Are you following? So therefore 2 into x cubed plus, let me use this and expand. This and this what? X what? This and this what? 2x squared change in x plus what? X change in x squared plus x squared, the x plus what? 2x change in x squared plus change in x cubed. You have finished that expansion. Expand this 2. What do you have? 2x squared plus 4x change in x plus 2 change in x squared minus 3x minus 3 change in x plus 4 minus y. So you know that this is 2 of this. So you can grade that place to be 2 into, are you following me? Yes, sir. X cubed, this, you can add this with this. What do you have? 3x squared change in x plus this is added to this. What do you have? 3x the x squared, I mean, is that true? Plus the x cubed plus what? 2x squared plus this one doesn't have a brother plus 4x change in x, okay? Plus 2 change in x squared minus what? 3x. Then minus what? 3 change in x plus 4 minus, that minus will affect all these guys. Minus 2x what? Cube. 2x what? Cube. Minus 2x squared. What else? That one will turn to plus 3x minus 4. The minus now, that minus affects every element. So something is cancelled. I can cancel out this side if I expand that side first. So this will open up. What do you have here? 2x cubed plus what? 6x squared. These two touch every member from here to here. Understand? You know, see that cube. That cube cover. That this will cover till this place. Have you seen that? So expand so that from here you have this way the zinc up, that the x cube that you have. This is the place. Is that correct? Remember? So this is 2x cubed plus 6x squared change in x plus 6x change in x squared plus what? 2 change in x plus what? 2x squared plus 4x change in x plus 2 change in x squared minus 3x minus 3 change in x plus 4 minus 2x minus 2x squared. Let's start the cancel something here. This is 2x cubed. I've substituted y the other side. I've not seen it. I've opened now. So 2x cubed is gone with 2x cubed. What else? 2x squared is gone with 2x squared. I subtracted the minus 1 time before I move. What else? Minus 3x and plus x is gone. Plus 4 and this is gone. That's highest it can go. So you now bring out the remaining. That plus 6x squared change in x plus 6x change in x plus 2 change in x cubed plus 4x. So from there you answer as don't forget this is change in y. Change in y equals to, so you divide through by change in y. This is, look at, if you divide, this one is remaining 6x, this one will go, 4x is the answer. Minus 3, that's the answer. Have you seen it? So therefore this is going to be the change in y over change in x equals to 6x squared change in x over what? Plus 6x change in x squared over that, I mean, plus 2 change in x cubed plus 4x change in x over what? Plus 2 change in x squared over what? Minus change in x over change in x. So when you cancel, this cancel, what do you have there? This what? That one no need, I mean. This one no need, I mean. This one will go. This one no need. So you bring down the answer. I just want to bring down the answer. So my change in y over what? What is the last answer there? 6x squared. This one is 0. This one is 0, okay? This one is 0. What is there? 4x. This one is gone. Okay? This one. Clap now. Eh? My parliamentarians are here. God bless you. So, members, around there. So we have been able to bring out the value. But why I am saying to you? That is just the value. Eh? Is that? Yeah, I'm going step by step. This thing, I'm going to neutralize that thing. I'm not going to come. You don't know what I'm going to cause. I'm not going to say one. I'm going to say yeah. All right. So I want to believe you understand what is rolling here. Sir? So can I clean this up now? Can I clean this up? My friend, can I wipe this off?
Yes, sir.
I'm shifting it, I don't know. Are you true? Can I clear this off? So so if you have you have y, the general formula. Now, we are using this first principle to derive the general formula for the derivation. Huh? So what we now do is that, you know that if you have y plus smaller increment in y, okay, equals to x plus smaller increment in x in that from the general formula. That's the general formula for binomial expansion. What does the formula state for binomial expansion? Binomial theorem. That is that if you have x plus y to the power of n, that is going to equals what? N combination 0, x, n combination 0, then x n y 0 plus n combination 1, x n minus 1, y 1 plus n combination 2, x n minus 2, y to till you get to what? N combination r x n minus r y r. So you get to what? N combination n x n minus n y n. Are you aware of that? So if you have that binomial expansion done well, you are going to get that derivation. Are you aware of that? So, in that case, we don't expand that using that formula. Have you? What do you expand using that formula? So if you now have that, you have this place will now be y plus change in y equals to x plus change in x to the power of n So therefore my change in y will now be what? X plus change in x n minus y, okay? Minus y. That is to say that my change in y, if you expand this, what do you have? N combination 0 x n, then change in x to the power of 0 plus, have you seen what I'm doing? Plus n combination 1 x in the what? N minus 1, then change in x to the power of 1 plus what? N combination 2 x to the power of what? N minus 2, change in x squared plus 2, you reach n combination n, then you have x n minus n, then change of x squared to the power of n minus yn, which is what? Minus, this is where n means y, that is xn. Are you following? Eh? I hope you are not disturbing. Eh? Or have you seen it? Eh? So from there, this is going to be changing x will now be n factorial into what? 0 factorial, n minus 0 factorial, x to the power of n. This is gone, have you? Plus n factorial into what? 1 factorial, n minus 1 factorial, x to the power of what? N minus 1 plus n factorial into what? X n minus 2. Is what follow? Till you have x n, get that n. If you can get these 3, other one are bonus. So this is gone. Eh? Change in x. This is n combination 0. X n. This is changing. This is changing y is in this side. That one is typing error. So this place, you know that n minus 0 is n. What's left there is xn. That is changing y. N, this is 0 factorial is 1. N minus 0, this is 1. You have xn there. Plus what? N into, if you arrange this place, you have something like this. N into n minus 1 factorial all over n factorial. So this one cancel out. You don't understand? That is this place. This is what you have there. You have something like that here. This place. N factorial over what? N minus 1 factorial is n times n minus 1 factorial, all over n minus 1 factorial. This cancels out. Eh? Is that true? So this place will now be n. That is n into n minus 1. So this, the whole thing will go. What we have n is the x n minus 1. Change in x. Plus, coming back to this, if you expand this, you have You have n into n minus 1, n minus 2 factorial, all over what? N minus 2 factorial. Then 2, this cancel out. Have you? So you now have what there? N into n minus 1. Have you? Are you following me? All over 2. Then x to the power of n minus 2, changing x2 plus. Huh? You don't have any option than to believe me now. So from there, this point, you see, there is no way you can have this thing, how do you call it? By dividing through by changing x. I can say dividing through by changing x. So dividing through, ikaw magaram from me. Now spell through. Divided by changing x, changing y over changing x will now be what? This one. You have that. What? Dividing all by changing x. Oh. This one has change in x now. Dividing by changing x. So this place will have x n over changing x plus nx n minus 1 changing x over changing x plus n into n minus 1 to factorial x n minus 2 changing x squared changing x. All of them, you know, we're going like that. So from there, by changing y over changing x will now be equal to xn over changing x plus this cancel out this. President, this cancel out is what you have. Nxn minus 1. This 1 will remain here. As it goes, it will remain like that. So without anything that changes into 0, including this one. So my dy over it, my change in y will now be what? Nxn minus 1. That's the formula. Come on. So that is that. Whatever is changing, you can't turn it to 0. And from the formula. So we are not, don't panic, we are not using these ones. We only use the formula. I know you are afraid. Is that? Okay, from what I'm saying. No, you don't need all these things. What you need is, see, the only thing you need for this business is this. That's I didn't make it up. Here you go. Where is it? Okay. Okay, 70 hours. Who am I to say no? Who gave me the mess of marketing? I never get home. So, no, we are just division. We are starting a new number. You don't understand what I mean. So I wanted to know the number. Last ball, just a smile. So we derive formulas. So when we talk about binomial theorem, we'll just laugh because that's my surname. We are just starting. Other one we are doing was we were just this. Now we start maths. Today is a welcome address. I'm just starting. This was the long-awaited mathematics has arrived. So let's try to see how we can. Okay. I can mirror. That's mirror. Okay. All right. So I believe I can clear it off now. Okay. Hello. All right. So now let's just try to apply the applicable. All right, so since we have been able to derive formula for for the general formula, we now know that y equals to what? Xn. We did not just carry from somewhere, we derive. Because most of this business we are going to be deriving formulas so that you know in case you forget. So you know that the y over the x equals to, that's if y equals to x and the y over the x equals to what? Nx n minus 1. That's derivation. Abi? So if y equals to k xn, the y over the x equals to kn xn minus 1, that's a constant. Bring it down. And if y equals to c, the y over the x equals to 0. So you mention a constant. So since we know that, box. Yeah, move. Let me just greet you. Sorry, this person is a war. Thank you. Anyway, I'm grateful. All right. All right. Now we have that's permanent marker. That's permanent marker. Huh? Yeah. How do the marker even take the?
I don't know who put it.
You think show me now? Okay. So let's see how we can. We understand this fact now. Eh? So with that, you have y equals to 3x to the power of 4 minus 3x plus 3x 6x squared minus 2x plus 4. If y is this, find the y over the x. Now from that formula, what you now do is that remember that this is the y version. So the y over the x will now be what? What is that? 4 times it is what? 12x. Okay? Plus what? 12x minus 2. Constant is gone. Okay? So that's how you differentiate that. But if you have a case that's, let me say, y equals to minus 3, x to the power of minus 2, plus x to the power of minus 3 over 2, plus 4, plus 4x, say differentiate that. This one. Okay. What you do there is that is this one. When they say y, it was a 3x 4 plus 6x squared minus 2x plus 4. This one will come down. Is that what you want? The y over the x equals to 3 times 4 x 4 minus 1 plus 6 times 2 x 2 1 minus 1 minus 2, no, x is to the power of 1 x 1 minus 1, any constant is 0. Are you getting it? So this is what? 12 x 4 minus 1 is what? 3 plus what is here? 12x 2 minus 1, 1 minus 2 x 0. Okay? Because if you multiply that, it's gone. So this is what? 12x to the power of 3 plus 12x. Any number to the power of 0 is what? Minus 2. Which place? Huh? I want to solve this one. All right. Are you sure with that? All right, now, so let's see how we can expand this. You have y. What is the power of x here in this one? What about this one? So let's bring it up to this side so that we can solve it. You have y equals to minus 3x minus 2 plus x to the power minus 3 over 2 plus 4 over x. I mean? Plus 4 over x. That's the question. So what do we do here? See, the y over the x equals to this. What happened here? Ben box. This one will come down. Minus 3 times minus 2. X minus 2 minus 1. Are you following me? Then plus x minus 3 over 2 minus 1. Are you? You know, this is just I say, you know, this place is 4x to the power of minus 2, have you? So, minus 1. So when you come down, that would be minus 1 times 4, x to the power of what? Minus 1 minus 1. Is that true? So, this 6x minus 3, minus 3 over 2x. 2 times 1 is 2. Minus 3 minus 2. Have you? Minus 4x. So this will now be equals to what? 6 over x to the power of 3 minus what? 3 over 2x minus what? So you have they are copying. The guys, Bible is copying. All these pictures with this, now what did they keep out? Now let's see how we can What was 17? Now, if you have a case that y goes to Now, if you are given a question, how do I say that? Okay. Now, since you've been able to know those formula now, right? If you look at questions, hello? But now you are distracting. What's your problem? When they give you differentiation, they give you in different formats. Are you getting me? Now, the beginning, most people doesn't know the specified rule to use in order to solve. But as you are starting, if you follow up step by step, because in a question, they will just tell you differentiate. They will not say using product rule, or using chain rule, or using function of a function. Are you getting me? Or hyperbolic function. What they just say will be differentiate. There's only one thing that sometimes they specify. Maybe they say differentiate implicitly. So they normally like to use specification in differentiation. Are you getting me? Even in integration, calculus as a whole. So the ability for you to know the particular version to use to solve is determined by your capacity. That's the time you spend in understanding calculus. Are you getting me? So as we are starting, you need to follow up so that when we get to the top, you can understand each of the topic. Because there's no student, so long whether you are in the university or you are in the polytechnic, wherever you are, you not run away from calculus, you do it. If you don't do it in your first semester, you do it in your second semester. You understand what I mean? So, is that clear? Can we proceed?
Yes, sir.
So, the first thing you need to know is that the one we just finished solving is a general formula. Anything that you don't see in the bracket, an explicit function, you should know that it doesn't need any formula, that general formula is involved. But the starting point of using formula start from function of a function. That is composite function. When you have a function inside a function, for example, you have y equals to 3x plus 5. If I say differentiate this, you know it's easy. What's the version of this now? The y over x. The answer is 3, have you? The answer is 3. Because constant is gone. If you replace this, what do you have? 3. But if you now put it in a bracket, maybe they say y equals to 3x plus 5 to the power of 4. You see, another problem has come now. Or they say y equals to the square root of 4x minus 3. You cannot use that formula y, that is maybe nx n minus 1 to do this thing. It's wrong. Are you getting me? Because all of them has different formulas. So when you see a function inside a function, just like, look at this. This is a function of a function. What is a function? Look at this one. Another rule. Product rule. This is another rule. Quotient rule. So for you to know all this rule one by one, is for you to follow this course as you are starting. Because today, when are we ending this program? Today is what? So Thursday, I'll use Thursday, Friday, Saturday, I will teach calculus. I will teach indices. I will teach differentiation and I will teach differentiation, integration. So the way I will teach it, application, everything. So it's just for you to be ready. It's not something that when I'm teaching, you'll be, because this one is not like the one we just finished, that if you don't know indices, you will know log. If you don't know set, you know binomial theorem. This one is not like that. This one is step by step. As I'm starting, if you fall along the way, it's difficult to follow up. It's a ladder. But because as I want to start, I will start from the basis. Then I'll take you to the speed lane. So if you are ready to learn, if you miss along the way, you don't follow us again, you just wait and we're counting your numbers. But if you know this one, for those that you, different schools, engineering students, you are going to do this thing till you do it in your year 2, year 3, final year, PhD, masters. You still do this calculus. You just call it calculus 1, calculus 2, advanced calculus, but the same basis, the same principle. So I hope you are ready.
Yes, sir.
If you are not ready, I will know. Yes, this thing is beyond the record. Record is after Monday or Tuesday, we break the record. But what is in your head, you cannot break. So, it's beyond the record. So let's proceed. You cannot come and stay for 1 week and you don't have something upstairs. That's bunkum and balderdash. I'm wasting my time teaching you don't understand anything. People outside, they will watch and you don't learn. No. So let's proceed. So y equals to, no, sir, see, after the general formula, after the general formula, if they give you a question like y equals to 3x plus 5, you differentiate this one directly, right? But if you have something like, let me say, 6 on top, it's a function inside a function. So in a case like this, you apply the method called function of a function. Which is called a chain rule. The formula says that the y over the x equals to the y over the u times the u over the x. Are you getting me? So how do we do that? How do we do that? If you have the value of, please, are we together?
Yes, sir.
If you have this case now, a case like this, you now say y equals to 3x. What you now do is now, you say, let u have you seen that? So when you now put u here, y will what? U to the power of 6. Is that clear? It's my people. So, y equals 3 to the power of 6, have you? Let u equals to that. So, this place will turn to u. When it turns to u, this place will be what? U to the power of 6. So, if I slip, if I differentiate u, If I differentiate to you with respect to x, if I differentiate to you, if I differentiate to you with respect to x, I will have the u over the x. Eh? Are you hearing me? If I differentiate to you with respect to x, I have what? The u over the x. Eh? But if I differentiate y with respect to u, I have the u over the x and the y over the x. What did I say? So what is the need of me teaching? I said if you differentiate u with respect to x, you have the u over the x. If you differentiate y with respect to u, you have what? The y over the u. So therefore, this formula is just waiting for you to do two things. One, differentiate this. Second, differentiate this. Multiply is over. Huh? Is that? So let's proceed. So what you now do is that you now say the u over the x equals to, differentiate is what you have? 3. Have you? Differentiate this. The y over the u. Differentiate u to the power of 6. 6 will come down. Have you? That's all. Bring the 2 to the formula. The y over the x equals to the y over the u times the u over the x. Eh? Yes. So that will be, what's the y over the u? I mean, 6u to the power of 5. What's my u over the x? I mean, 6 times 3. 18u to the power of 5. That will be 18. You now replace your u. What was your u? Eh? Replace it there. That's all. Is that clear? Yeah? So now let's proceed. So if they give you something like this to do for me, believe you can solve it. Huh? So I want you guys to solve this for me. What was the 6x minus 5 to the power of minus 3?
Minus 18.
Let them solve.
Minus 4.
Let them solve.
Minus 8 times 6. Minus.
So you need the result.
All right. You see that with what we have seen here, differentiation is simple. Just understand the principle involved. When you get the principle involved, you can do anyone that you wish to do. All right, now have you finished that what I'm giving to you? The 6x if you differentiate if I differentiate that, did you use the method I showed you? Let u equals to you assign u to the particular number you are looking for. When you now let u equals to that value, you now differentiate. When you differentiate, you have the u over the x, you have the y over the u. You now multiply the product, the value. When you now multiply, you get the answer. So let's continue. What do you have? Next question. Let u. So y equals to what? U to the power of minus 3. Is that correct? The u over the x equals to 6. What's by the y over the u? Minus 3 u minus 3 minus 1. Is that true? Then that will be minus 3u to the power of minus 4. Is that correct? Is that correct? So you can still present this thing as by the y over the x equals to the y over the u times the u over the x. Is that true? So what's by the y over the u? Minus 3u. Then what by the u over the x? So from there, this will give us what? Minus 3 times what? 18. U minus 4. So you now bring this one up, that will be what? Minus 18 over u to the power of 4 because it comes down. It becomes minus. That will be minus 18 over, return back your u, 6x minus 5. So that's how you differentiate Now, if you have any value to differentiate, just apply the formula in terms of quotient rule, in terms of chain rule. That's if you have a function inside a function. Just differentiate. Is that clear?
Yes, sir.
So let's proceed. All right, so if you have a case that you have y equals to 2x plus 5 to the x minus 2. You see, you cannot use that method and solve. Because that method is for a function inside a function. But this one has a separate function, a separate linear equation. Are you getting me? A separate linear equation. So when you have a case like that, what you now do is that you apply a formula called product rule. Because this is a product. Are you getting me? This what? Product. Product rule. When you have division, quotient, the name, what you see reminds me of a name, a formula you are using. Are you getting me? What you, the kind of question they gave to you determine the formula you are using. So if you now have this, the y product rule, okay? What does the product rule says? The y over the x. That formula for product rule. So anytime you see a case that has to do with multiplication of products, what you do is that you remember the product rule. Remember what? The product rule. So in the product rule, one side is u, this side is v. Or this side can also be v, this one can be u. You should have the same answer. Anyone. But in quotient, the up must be u. It's a must. The up must be what? U. And the down must be v. So, my v is what? Now say let u equals to 2x plus 5. V equals to what? 3x minus 2. So we now have that. We differentiate the u over the x. We have to, okay? Is that clear? This is normal. So you have that the y over the x equals to v the y over the x equals to v that's the formula, right? Is that the formula?
Yes, sir.
So, what's my v? What's my du over the x? What's my u? What's my dv? This one was du. This one is dv. One is du, one is dv.
X is 2.
What about the v over the x? Yeah, that's the thing I'm looking for now. Hmm? So, Ari, what do you have here? So, yeah. I gotta do it. What was I gonna do? I just finished something. All right, I've just finished solving that one. Have you?
Yes, sir.
So I want to give you something to try for me. Just try something for me. Let's see how it goes. On product rule. You know product means multiplication.
Yes, sir.
Brother, have you seen something passing here? No. Eh? All right. Now, from what you've seen here, you can agree with me that product rule is all about knowing the two functions and differentiating them. Let me show you the tricks involved in this business. Look up, see, this is a question, have you? Eh? Please look up, stop writing. This is your paper. This is your student ID card. This is a question, eh? Look up. I have two questions. Huh? So, I will write one. I will just write one. Huh? Then, I differentiate one. If I differentiate, what do I have? That's a 2. Eh? Then, I write this one. I differentiate this one. What? You understand what I mean? So that's the meaning of that stuff. Sir? You don't even understand? Nah, you don't me have your friend. Sleep, don't worry now, right? You got them. It's not as bad as just not to sleep. It can weigh you down mercilessly. But I tell you what is happening to me. People don't have problems now. I need a problem. Yeah. Yeah, so please, let me give you something to try for me right away. You have y equals to 6x minus 3, 4x plus 5. Do that for me, let me see. Just solve that, let me see. If you get that, we flow to the next frequency. No, darling. You see, that's why I always tell you that. Is there AC in this house? The AC give people energy. AC. Yes, energy to sleep. All right, so you have the product rule, so that we just take one, differentiate one, and the list goes on and on. You understand? So after we do the product rule, we will now talk about another rule, which is quotient rule. And we do function and function. So please, when you have to differentiate that, remember the general formula for differentiation. And I've gotten the answer. My friend, yeah. Did you have the answer? You don't even know how to start. What are you giving us, bro? What are you wanting? Berapa nama saya yang uang itu apa? Mas I amend the constitution. So the value of product rule is, have you been able to get that? So, what do you have? 48 48x squared plus 18 Well, anyone have a different answer? Anyone has a different answer? Different answer from what we had there. U equals to 6x minus 3. U equals to U do is and V is that. Is that right? So the U over the X. So the Y over the X will be applying product rule, right? Product rule, the Y over the X equals to V over the X plus U. Is that true? What's my V? 4x plus 5. What's my D over the X? What's my U? The V over the X. So 6 times 4 plus 20. 24x minus 12. Is that what you have? Is that what you have? Yeah. You are correct. This is 24 minus 12, right? So, what do you have next? No, sit down for your seat. Somebody wants to do it. Don't do your seat. 48x plus what? Hope you understand it right. Eh? You know how to do product rule now. Beautiful. So, because we are going to progress to the next level, which is a so let's go to quotient rule. For quotient rules we have quotient rule. The word quotient means division. Quotient means what? Eh? Quotient means what? Division. So that will be the Y over the X. The Y over the X equals to V, the U over the X minus U the V all over V squared. Now, this is the case that you have, maybe like you have Y equals to 2x plus 4, then 3x plus 5. And you have to differentiate. Eh? So in this case, what happened?
Up is U.
Eh?
U is equal to 2x plus 4.
E equals to 2x plus 4. V equals to what? 3x plus 5. Eh? So therefore, when you now differentiate that, you have that the u over the x. Eh? When you differentiate the up. Eh? So that will now give us what? The u over the x. Eh?
Yes, sir.
The u over the x. What do you have? Eh? What's the v over the x?
The U over the is 3.
Is that? How one of you are following?
Yes, sir.
Now the y over the x equals to what? V, the u over the x minus what? All over. Is that true?
Yes.
What is my v?
Your V is 3x plus 5. And
What's my d over the x? What's my d over the x?
2.
Minus what is my u?
Your U is 2x plus 4. Now the V is 3.
What's my dv over the x?
Is 3, sir.
Divided by v squared. What's my v squared?
Your V is 3x plus 5 all squared.
3x plus 5 all squared. Is that right?
Yes, sir.
So multiply, open the bracket, 3 times this what?
You have 6x there.
You have 6x
Plus 10.
plus 10
Minus 6x.
minus 6x.
Plus 12.
The minus will affect this one also. Minus 12. This minus will affect this too. Eh? If you stop here, you see, if you multiply this with this, you still have to open the bracket. If you don't open the bracket, it's not complete. Do you understand?
Yes, sir.
So that will be divided by what?
3x plus 5
3x plus 5 all
all squared.
squared. So 6x minus 6 is gone, have you?
Yes, sir.
10 minus 12. That equals to minus 2 divided by 3x plus 5 divided by 2. Copy that. So you have to find now, you know, in each of the example I've shown you, I need to show you the simplest method you apply. Water. Now, remember what I told you the other time when we talk about if you have a product rule. I said the product, if you have 2x plus 4, 5x plus 3, I told you that if you want to differentiate this, what do? I tell you something like that. Keep one, differentiate one. Keep this one, differentiate the other one. So I said, that's right. Okay, as if this is my right. This is my left hand side and this is my right. What do you do to make it easy? Just do like this, left, differentiate right. Right to your right, differentiate left. So what's my left now? 2x plus 4. Differentiate right. What if I differentiate it, what do you have? Right to your 5 plus, bring your right hand and right. 5x plus 3. Differentiate left. Differentiate left, what do you have? See, from there, you know, you have finished your differentiation, you expand. That is for product rule. But coming to this one, something to remember. is, if you see this up, if you observe very well that what you have in this down and what you have in this up in the question as reflected back here, have you observed? Check, you see. What is this? Is the one for up. This is the one you have for down. Have you observed? Now, this two is the differentiation of what? The two is the one differentiate here, and the 3 is the one differentiated here, and the down is this one. So what you now have to remember, there's a method you do. They call the method bottom, the top. That is, if you have this up, you know this is top, and this is what? Bottom. Are you getting me? So what is here? What is here? This is bottom now. Okay. Now look at this. I mean, this 3x plus 5 is what? Have you seen it? Bottom, right? These two, I am differentiating. What am I differentiating? Is it top or bottom? Top. This one is what? Top. These 3, what am I differentiating? What is here? Are you getting me now? So for you to understand Poisson rule, what you now do is that the formula is you just say bottom, then the top, minus what? Top, the bottom, all over what? Bottom squared. That's the formula for question 2 that will make you remember. In the next 100 years, you will not forget. Have I forgotten it? Because that's the way I was taught. And so I just want to give it raw the way I know it. So the formula says bottom, look at it, keep the bottom, differentiate the top. If you differentiate the top, what do you have? 2. Look at the 2. Minus, right top, look at the top. Differentiate bottom, differentiate the down. Have you seen it? Divided by what? Especially for brain boys that have light brain, so they will not forget. Is it? So when the way come around big. So when come around big. All right. Now we've been able to understand. You will not forget quotient rule, product rule. Did I use it? Now, can I proceed? That's my essay on sound matters. Now differentiate. That value we have y equals to 5x plus 3 divided by 6x minus 2. What is this? Which rule is this? Quotient rule. But nobody will tell you using quotient rule. So, what we are going to do now is that after this differentiation of quotient rule, we are going to enter the next page. But we need to know, as I've seen you, let me use it. Don't worry, no. So I'm not doing that. So, if you have any question that they give to you to apply, just understand that rule first. The rule that is given to you first. When you know the rule, you can solve, because differentiation and integration is not difficult. Just for you to understand. Have you finished? I want you to solve this one for me.
-2.
What do?
6x -2.
Have you finished? Okay. You don't have problem for this one. It's as if my head is not with me. So we need to find. What's the answer? What answer do you have? Huh? Minus what? Minus what? What do you have? Another option. Another option. All right. Okay. Have you tried? Do you have any answer? What is it? So you need to differentiate. When you get that idea, all those little tricks that I show you, even if you don't remember how to solve the thing, that thing will guide you to remember the formula. And you don't know the formula, you can do whatever. You understand? Okay. What's the answer? What answer? 28 over. Why are you people having different answers? Is it because you are from different family? Something those who have one answer. This one will tell me another answer. Or you don't trust yourself in math. All right. Let's see. Let's see what will happen.